We are going to look at section 6.4, equations with rational expressions. So let's start with the directions. So a rational equation is an equation as such where you have a variable in the denominator. We have not solved an equation like this before. We have solved linear, where there is no powers on the variable and there is no variable in the denominator. We have solved quadratic equations where we have a power but still no variable in the denominator. So here's a new type of equation for us. So we're going to determine the values that make any denominator equal to 0. Then we're going to find the LCD for the entire equation and write equivalent fractions. Using this LCD for each part of the equation. Now we're going to write and solve the numerator parts of the equation, or we're just going to pull out the top of the fractions and solve that equation. We're going to check our solutions to the values stated in step 1 to decide if they are allowed. So let's try our first one. I'm going to say that the number that x is not allowed to be is 0, because if 0 was in this denominator, I'd have 8 over 0, and that would be undefined. So my first step, when it says determine the values that make any denominator equal to 0, I'm going to say that those are values that x is not allowed to be. So if this x was 0, this denominator would be 0. So x cannot be 0. Now my LCD, I only see one fraction, x. These others are over 1 right now. So I want everything over x. So if I put x in the bottom, I must also put x in the top. So x times x is x squared. This fraction already had x, so that's still 8. And if this 1 becomes an x, then negative 9 needs an x. Now I can see that all across my equation I have the same LCD. So I get to peel out the top and solve this equation. So I get to solve x squared plus 8 equals negative 9x. Now we have to recognize how to solve this equation as being quadratic. Since it has a power of 2, that means it's a quadratic equation, and we have learned how to solve quadratic equations by setting them equal to 0. So I'm going to add my 9x. So I get x squared plus 9x plus 8 equals 0. I am now going to factor my quadratic equation. I'm going to say x times x, I'm going to say plus 8 plus 1, because those numbers multiply to 8 and they add to 9. When I'm solving a quadratic equation, I set each factor equal to 0 and solve. So I get x is negative 8, and I get x is negative 1. I check these answers against what x is not allowed to be. So x was not allowed to be 0. Well, neither of these are 0, so I get to keep both of these answers. Let's try again. Number 2. First, I want to figure out what makes these denominators go to 0. So what would x need to be when I would take 1 away from it to get to 0? Well, if I had 1 here, 1 minus 1 would be 0. So x cannot be 1. Now my LCD, I see an x minus 1. I see an x minus 1. So this needs an x minus 1. So I'm going to write 5x over x minus 1. Equals 5 over x minus 1 plus I need this to be x minus 1. So I have to multiply 3 with x minus 1, because whatever I do to the bottom, I do to the top. Because remember, right now it's just 3 over 1. Now I get to peel out the top. So I get 5x equals 5 plus I'm going to distribute 3x minus 3. Now this is a linear equation because I have no powers. I simply want to pull all my x's to one side. I'm going to combine these terms. So I get 5x equals 2 plus 3x. I'm going to subtract 3x. I'm going to get 2x equals 2. I'm going to divide by 2, and x is 1. Now, for rational equations, equations where you have variables in the denominator, I must check my answer against what x is not allowed to be. Well, x cannot be 1, and that's the only answer I got. So I can't keep that, and I'm going to write that there is no solution for this equation. All right, let's try again. Now remember, the first thing that we have to find is what makes any of these denominators go to 0. Well, that's not very easy with these denominators written as trinomials. What would make it easier is if we factored these out into smaller factors. So we're going to factor this, and we're going to get x and x. We want to multiply to 24 and differ by 2, so I'm going to say plus 6 and minus 4. We're going to factor this one. So I'm going to say x plus 5, x minus 4, and we're going to factor this one. I'm going to say x plus 5, x plus 6. Now notice there are 3 different factors down in these denominators. X plus 6 is 1, x minus 4 is 1, and x plus 5 is 1. So I need to state what x cannot be. So the value here that would make this set of parentheses 0 is negative 6. So I can't use negative 6. This one, I can't use 4. And this one, I can't use negative 5. The reason why I can't use any of these numbers is because these factors are in the denominator. And if any of these factors go to 0, the whole fraction is undefined, which you can't have in an equation. Now what I'm going to do is I'm going to build my LCD. So we build our LCD by seeing what is missing from this denominator. So I have x plus 6 and I have x minus 4, but I do not have an x plus 5. So this fraction needs that. So I'm going to do 4 times x plus 5 over x plus 6, x minus 4, x plus 5. Plus, this fraction is missing x plus 6. So I'm going to write it in the top, and I'm going to now have the denominator I need. Equals. The third one does not have x minus 4, so I'm going to say 3 times x minus 4 over x plus 6, x minus 4, x plus 5. Remember, you are trying to make all these denominators the same. Once you do that, you solve the top of the equation. So I'm going to distribute 4x plus 20 plus x plus 6 equals 3x minus 12. I'm going to combine like terms, so I get 5x plus 26 equals 3x minus 12. This is a linear equation because I see no power, so it simply means put your x's to one side. So 2x plus 26 equals negative 12. I'm going to subtract my 26. I get 2x equals negative 38. I'm going to divide and get x is negative 19. I must check this answer against what x is not allowed to be. I don't see it in my list, so here is the answer to my equation. X equals negative 19. This one, I only see one denominator. What would make this denominator go to 0? A 2. So x cannot be 2. Since this is the only denominator I have, I need to make every other part of this equation have this x minus 2 in its denominator. So for x, if I put x minus 2 in the bottom, I need to take x times x minus 2. Plus, 14 already has x minus 2 in its denominator, so we're good. Equals 7x over x minus 2. Plus, if 1 needs x minus 2 in the bottom, it needs x minus 2 also in the top. Now I see that my denominators are the same across, So I am going to peel out the top. I get x squared minus 2x plus 14 equals 7x plus x minus 2. I'm going to combine. So I get x squared minus 2x plus 14 equals 8x minus 2. This is quadratic because I have a power of 2. Power of 2 equations we have learned to solve them by setting them equal to 0. So I'm going to subtract my 8x, and I'm going to add my 2. I get x squared minus 10x plus 16 equals 0. To continue solving a quadratic equation, you are going to factor. So I'm going to find factors of 16 that get me back 10, negative 8 and negative 2. I set each factor equal to 0 and I solve. So I get x is 8 and I get x is 2. I must always check my answers against what x is not allowed to be. X cannot be 2, meaning this x equals 2 I cannot keep. But this other answer is allowed. So my one answer for this equation is 8.